Writing basic role-based authorization like this is incredibly simple, but there's a reason that most senior developers don't write code like this. And that's because it quickly devolves into these massive nested if-else conditions that are not only difficult to read, but also difficult to maintain and use inside your project. So in this video, I'm going to be showing you an alternative that not only explains this entire permission, but actually sums up every single permission in our entire application in just about 10 lines of code using the Casl library. And on top of that, I'm also going to show you how to create really simple helper functions that make using this throughout your application painless. And best of all, I'm going to show you how you can connect this automatically with your database. So that way, every time you query information from your database, it automatically takes into account all the permissions of the user and only returns the actual database records they have access to, so you never accidentally expose information you're not supposed to. Welcome back to Web Dev Simplified. My name is Kyle and my job is to simplify the web for you so you can start building your dream project sooner. And to talk about permissions, we have a relatively simple application that has the ability for different users to create to-dos, and we can view all those to-dos on this homepage. We have this My To-Dos page to view only the to-dos of the current user, which we can modify however we want. We also have the ability to view all the users inside of our application, and currently there are absolutely no permissions set up. So non-admin users can access this page. As you can see on the home page, I can, for example, modify the user and the admin's to-dos and my own to-dos, which is obviously not what we want. So we're going to go ahead and actually implement the permissions for this application, and we're going to be using Casl for that because I find that this library makes using permissions really, really simple. Now to get started with Casl, we're going to go over to our application. We're going to open up the command line, and if we look at the actual Casl documentation, there's a bunch of different libraries, but the most important one we care about is this @Casl ability library, because that's going to be what handles all of our permissions for us. All these other libraries such as React, Vue, Angular, Mongoose, they're just for integrating with different databases and different front-end frameworks. The React one I find is really not that useful, so I'm going to show you how you can implement a much better version than this React library version, because it doesn't work super well with server components and so on. So if you're trying to use it with next.js, it just won't work, which is why instead I'm going to show you how to create your very own version of these different React components and so on. Now, once we have that library installed, we need to go ahead and start implementing our permissions, which is by far the easiest part of this, which is really nice because normally, as I showed in the intro, it can be quite difficult and complicated. So in our code, don't worry about not understanding every single function and file in here. I'm going to be going through them as they become important, but we're just going to go into this lib folder and create a brand new folder for permission related code. We'll just call it permissions. And then inside of here, we're going to create a function called getUserPermissions. Just like that. And this is going to return us all the permissions for our user, because the way that Casl works is you essentially just call a function that gives you all your permissions, and you can do whatever you want inside that. So we can export a function called getUserPermissions, and all we want to do is just pass a user into this function. Now I'm using betterauth for my user information, so we can actually type this by getting type of auth, and then we specifically want to get the infer property for our session, just like that, and we want to get the user property from that. So now we're getting all of the user related information, and we're going to be using that inside of here. So now I can, for example, get my user's role that I have inside of here, or their email, or various other properties for that. Now, if you want to figure out how to set up betterauth, I just released a massive 4.5-hour crash course covering every single thing about betterauth. I'll link it in the cards and description for you. But also for this user object here, we're going to make sure it's undefined because we also want to allow guest users in our application, and they will have certain privileges as well. Now to use the Casl library, we want to use this ability builder. So we can say ability builder, and we want to create a new version of this ability builder, just like that. And we may need to actually import this. So we can say we want to import this ability builder, and that comes from that @Casl/ability library. There we go. We now have that implemented, and we can come in here and we're going to get a bunch of things returned from this. And if we take a look, you can see we get can, cannot, rules, and build. We really only care about these first three. So we're going to get build, can, and cannot. Now I generally like to rename can to allow and cannot to forbid. So that way it's a little bit more self-explanatory. This is me allowing a permission, and this is me forbidding a permission, because we're going to use can and cannot later, so it can get a little bit confusing if you use the same name for both. So now we have these different variables that we can use, and if we come down here and we return calling the build function, that's just going to build all these permissions for us based on our allow and forbid functions that we call. So for example, I can come down here and I can say allow, and then I can pass in what I want to allow. For example, I want to allow anyone to read a to-do. So we can say now anybody can read any to-do. But generally, I don't want them to read private to-dos. I only want them to read public to-dos. So I can come over here instead, and I can say that I want to make sure that public is set to true. Now, essentially what I'm saying is I'm allowing any user to read any to-do that is marked as public. Super straightforward. But I also want the users to be able to read their own to-dos. So I could say if the user is not equal to null, well then I want to run some other permissions inside of here, such as allowing them to read and I want them to read all of the to-dos, whoops, all of the to-dos just like this, where the user ID is equal to their ID, which is just user.id. So now we have two different permissions. Any user can read any to-do, and also if you're logged in, you can read all of the to-dos that are your own. So you can read any public to-do or all of your own to-dos, even if they're currently private. So this right here at least gives us the ability to read various different to-dos. We can also come in here and say if the user.role is equal to admin, well, I want admin users to be able to read every single to-do, so I can just come down here, and instead of having a prefix down here for the different categories for things that need to be true, I can just say they can read to-dos. And now what this code says is they can read every to-do, no matter what. If it's private, public, user ID, it doesn't care. It just says you can read every single to-do. And now what's going to happen is every time I call get user permission, it's going to run through with the user I pass in. So it's going to check, is the user logged in? Is the user have these permissions? So it's just going to check my different checks and just give them the different permissions I want. So for example, they can read public to-dos, they can read their own to-dos, or they can read all to-dos depending on if they're admins, users, or not. And this build function that I called down here essentially returns to me a permission object that I can use. So what we can do is we can just say get user permission. We'll pass in undefined because we don't have a particular user. And we'll just say const d is equal to that. And now you can see inside of here, I can call can and cannot, and that allows me to check these permissions. So I can say can read to do, and now this is going to check, does the user, with this undefined permission, can they read any to-dos? Or I can pass in a to-do object. For example, we could say public true, an ID of like 1, for example, like that. And I can pass that in instead of this title of to-do here. And now it's going to check, hey, do they have permission to read this public to-do that has an ID of 1? Now we are jumping a little bit ahead of ourselves looking at the ways we can use those permissions though, because as you can see, we still have an error inside of our code. And that's because this ability builder actually takes in an argument, which is the way that you want to build your ability. There are two different ways. There is a pure ability, which is essentially an ability with no way to do things on its own. You have to implement everything else on your own. And then there is a Mongo ability. So we can say create Mongo ability just like that. Now you may be thinking, oh, this only works with MongoDB or something like that. But the way this create Mongo ability works is it just uses the MongoDB database syntax for doing different things like checking equality. We can also come in here and we can do things like checking less than or greater than, just like that. However it works inside of MongoDB, you can do all of those, your checks inside of here. It just doesn't actually use MongoDB behind the scenes. It just uses the query language that they use. So that's why they call it a Mongo ability, but you don't need to be using MongoDB. And in this tutorial, we're using Postgres and Drizzle, so it has nothing to do with Mongo at all. And again, all this ability type does is it just determines what this third parameter is. In our case, it's reading this and essentially putting it through the MongoDB query. As you can see, we have all these things like equals, not equals, less than, and so on that we can use if we want to. Now in our case, we're not going to be using the forbid function here. We're just going to allow certain people to do things because generally you don't need to forbid things. You need to allow things for the user to do. So this is essentially the most basic version of setting up these permissions. But right now we don't have any type safety at all. So I'm going to show you how you can implement type safety into this because I find that super, super important. So this ability builder actually is a generic. You can pass in different things to it. So in our case, we want to pass in the Mongo ability generic, and that's because we're using this create Mongo ability. And this actually is a generic as well, where we can pass in any type we want. I'm just going to call this type permission. So now we have this permission type that we can create up here that's going to determine what our different types are going to look like. So we'll come in here, type permission, just like that. And our permission type is going to be a union type where we essentially determine all the different things we can do in our application. So it's going to be a union of arrays. So we can have multiple arrays like this. The first property of the array is all the actions. So example, read, update, create, delete, all those different things. In our case, let's just come in here with read, create, update, and delete, because those are the 4 different actions we can perform on a to-do. So we're going to make sure that this is a union because we want this to be the very first property inside of our array. The second property in the array is going to be the thing we can do this on. In our case, we are going to be doing this on the to-do object itself. So we put in to-do just like that. That is going to be our first set of permissions. Our second set of permissions is going to be what we do for our user-related information. In our case, I only want to be able to check if a user can read to-dos, or users, I'm sorry, because we have no way to create, update, or delete these. So we'll just come in like that, and we can say that the type right here is going to be user. Now, if we give that a save, you'll notice for the most part it's working, but you can see here that it's not able to get these different keys because it doesn't know what these keys for our to-do object is. So we need to create 2 different types of subjects. We need this to-do subject, as well as what happens when we want to pass in an actual to-do itself. For example, checking the public property or the user ID property. So I'm going to come up here. Inside of Casl, these are called subjects. I'm going to say to-do subject, just like that. I'm going to set this equal to getting my types from, so we can say type of, and I want to get that from my to-do table. This is from Drizzle directly, and I want to just do a quick getting of that information. There we go. I want to infer the select, and that's going to get me all the properties of my to-do table. Now, specifically, I only care about public and user ID, so I'm just going to pick the actual properties I care about, which are public and user ID, just like that. So that gives me my to-do subject, and what we can do is we can just union that with that to-do type here, that string, because that's what we're using right here, and that gives me everything I need to know about my to-do object. And you can see now it gets rid of these errors right here because I'm purposely making sure I type that information for what happens when I pass an object and what happens when I don't pass an object. So now if I were to just say get user permissions and pass it in no user, because for now it doesn't matter, we can say const p is equal to that. Now when I say p.can, I get type safety. You can see I get this. Now if I were to do read, you can see I get type safety for to or user. And if I wanted to pass in an object here, you can see I get public that needs to be passed in, and I get that user ID, which also needs to be passed in. Now all that information is properly passed in, and it can do the check for me. Now with that out of the way, let's go ahead and finish writing all the permissions for our application, because you'll see that it's actually quite easy to write once you get all your TypeScript stuff set up. So for example, we want all users to be able to access all public to-dos. We have that already. Once a user is logged in, we want them to be able to read, update, delete, and edit all of their different to-dos if they are the owner of those to-dos. So let's just copy this down. We're going to have update, we're going to have create, and we're going to have delete, because we want them to be able to do all of these different things, and we want them to be able to do them to any of their different to-dos, but we only want them to delete to-dos that are not public. So you can't delete a public to-do, it just must be there forever. So we'll say public false. So now if the to-do is public, this will essentially not work because it only allows them to delete to-dos that are public. Now we can move on to our admin as well, because we want to allow the admin to read all the user information. So we can say read user, they can read every user. That's how they're going to access this user table that we have on the right. And then we also want to allow them to update to-dos from other users, but we only want to allow them to update the complete property. So on this main page right here, admin users should be able to modify what the actual toggle for the to-dos are for every user as long as the to-do is public. But I don't want them to be able to modify what the name of a to-do is for someone else. I only want them to modify this checked property right here. So I can come in here and I can actually pass different properties that I want to be able to modify. So for example, I only want them to be able to modify the complete property, and I only want them to be able to do it on to-dos that are public, just like that. So now the admin users can mark public to-dos as complete, but they can't modify things like the name and so on. And this is all the different ways we can use this can or allow function. We can first of all just pass it in allow with an action and a subject, and that's going to allow them to perform this action on every single to-do inside of our application. Same thing here with users. We can also pass it in an object, and this is going to essentially do a different check for us. In our case, it can only read to-dos that are public, or only read to-dos that the user ID is equal to the current user. The final third way we can do this is passing in an array right here of all the different fields that we can modify. So in our case, we can only update the field of complete. If I passed in here, for example, fields to the read property, for example, complete, now the user that is an admin could only read the complete property of to-dos and nothing else at all. So this allows us to modify what fields they have access to. This allows us to modify what properties need to be in place for them to access that thing, and this modifies what the actual action is as well as the subject we're performing that action on. So we can get really fine-grained with our control all the way down to the individual field levels that we're modifying in our database. And all this stuff that we're modifying, I'm going to show you really easy ways to implement it into your code, because oftentimes when you start getting this complicated permissions, it becomes really difficult to implement in your code in a clean, reusable way. So now let's go ahead and save this file and actually start looking at our code for where we can implement these different permissions. One easy place is in this header section. We can implement this permission for this users attribute right here so that only the admin users have access to this, will be able to see the page and go to it. So let's go into our components section. That's where our header is. And if we look inside this header, you can see we have all of our different links for the main page, for the page for my to-dos, as well as the page for users. So I want to do a quick check here to determine does the user have access to this page. So what we can do is we can say get user permissions, just like that. That's going to be able to call that function, and we need to pass it a user. So we'll say session.user. That's going to get my user, which could be undefined, which is perfectly okay because we're taking that into account in our function. And now when I have this function, I can call the can property on it to determine can I do different things. In our case, I want to determine can I read any of the user information. If this returns true, it means that I can read at least one user that's inside of my database. It doesn't mean that I can read every single user, which is what you may think when you read this, but the way that Casl actually works when you're calling the permission checker is this is just checking, do you have permission to view at least one user in the database? It doesn't matter what it is, as long as you have permission to view at least one user in the database, this will return true, which is different than you may normally think about it, so just make sure you keep that in mind. But in our case, that works for our particular application. So we're checking, can you read at least one user? If that is true, then what I want to do is I want to render out this button code. So we'll just do this like that. So now if you have the permission to read the users, it's going to show the button, and you can see that button has disappeared because I'm logged into a non-admin account. If I actually sign out and I sign in as an admin user real quick, we'll see that that button will actually appear in the top right corner because now I have access to that user's page, and I can go to this page and view all that information. We can also, inside of our app, go to that particular page. So in our app, go to our users page, and we can do the exact same thing here to check our permissions. So we can just say that we want to get our user, which is equal to get current user, just like that. Throw a little await on there. And then we can say we can get our user permissions. There we go. Pass it in our user. And what we want to do is we want to check to see if they can do something. So we'll say permissions. There we go. And if our permissions.can, and we want to check to see if they can read the users. If they can read the users, then that's fine. But if they can't read the users, well, then we should redirect the user, and we should just redirect them back to the home page. So if they try to access this page and they don't have the permission to use it, it's going to redirect them properly. So now we're not only making sure the link doesn't appear, but we're also making sure we check on our server before we even send that information down to the users. So let's go ahead and actually test that. I can go to this page just fine here, but let's actually sign out, and we're going to log in as a normal user. So we'll say user@test.com, type in their password, and now you can see I'm on this page. I can't view the users up here, and if I try to manually navigate to the users page, it's going to redirect me back to the home page because I don't have access to that information. Now this is relatively basic permission checking, so let me show you how you can do slightly more advanced permission checking for seeing if a user can actually check a check mark on one of these different to-dos. So let's go to that home page inside of our application. We'll just navigate to that real quick by minimizing all of this down. And inside of our app, we're going to go to this page, and this is our home page for all of our different to-do related information. If we scroll down quite a ways, you can see this to-do checkbox component. If I comment this out, you can see that's what renders this checkbox on the left side of my page. So that's just all this is. So essentially, I only want to render this if the user has access to using this checkbox on our page. So we can do a really similar thing to what we did before. We can get our user permissions and we can pass it in our user information, which I believe we already have up here. This is the user for the particular to-do. I want to get our current user though instead, which it doesn't look like we're getting. So we just come in here and we can say const current user is equal to get current user. Make sure we throw a quick await on that. And now I can get my current user down here and I can check different permissions on them. For example, in our case, I want to update a to-do. So I want to update a to-do, but I don't want to update any to-do. That's what you would pass in here if you want to check, can I update any to-do? I want to check, can I update this particular to-do? So I pass in the to-do itself into here that I want to update. Then what I can do is I can pass along different fields and so on that I want to be able to modify. For example, I want to be able to modify the complete field on this property, because that's what happens when I check the checkbox, it'll mark this complete field. So now with this little bit of code in place, I'm essentially checking, okay, does my user have permission to update this individual to-do, and do they have permission to update the complete field itself? You'll notice though, when I do this, it actually gets rid of all of the different check marks on my page. The reason for this is because Casl doesn't know that this to-do object is actually a to-do element itself. The way that Casl works is it's best used with classes, and we're not using classes in our code, and honestly, for the most part in your front-end code, you're probably not going to use very many classes. So instead they have a helper little workaround you can use to essentially tell Casl, hey, this to-do object is of type to-do. So what we do is we call a function called subject. This comes from that Casl ability, so we can import that, and this subject function essentially takes in two different properties. The first different property is going to be the type of the thing, which in our case is to-do, and the second is going to be the object you want to mark as a to-do object. Now Casl is essentially saying, hey, this to-do object is of that class to-do that we have right here. Now when I give that a save, you can notice that my check marks automatically show back up. You can see I'm logged into my user account, so I can modify all the different complete properties on my user object itself. While if I sign out of this user account and I log in to my admin account, you'll now see that the admin actually has permission to modify slightly more things. For example, I can modify all the check marks on my properties and all the check marks on the public to-dos for the user account. And when I'm entirely signed out, you can see I can't modify anything at all. And all of that is tied directly to my permissions. So you can see once I set up those permissions, there's just a few lines of code I need to write to be able to modify and use these permissions everywhere in my application. The problem though comes in that a lot of the times you duplicate this code in many places. I'm going to call this exact same code on my back end as well to make sure it's properly checked there. So I need this code in my front end, I need it in my back end. So at the very least, I need it twice. And oftentimes there's multiple places in the front end and multiple places in the back end where you need this, which is why I recommend taking these types of code and extracting them out into helper functions. So inside that lib permissions folder, I'm going to create a brand new file called to-dos. And this to-dos file is going to modify all the permissions. So I'm going to export a function that says can toggle to-do. And what this is going to do is it's going to check, can my user toggle a to-do? And I'm going to be taking in my user information that I want to check, as well as the to-do information that I want to check. Those are the two properties I'm going to check. Now we can get the type information for those. We know that our user is of that auth type, so we can just paste that type in here. You know, it could be undefined or an actual user itself. And then our to-do we know is going to be a type of, and that is going to be from our to-do library. So that's coming directly from Drizzle. There we go. Whoops. Type of to-do, make sure we get that from Drizzle. And the reason it's not importing is because I probably should call this to-do table, and then we'll import this up here. Import to-do as to-do table. And I want to get that from @/db or drizzle/db. There we go. Now that's getting my to-do table information. And I think I actually need to get this from the schemas. So we'll say schemas. There we go, just get it from the schema. Now I have my to-do table and I want to infer the select property of this. And from here, I can essentially take the exact code that I had in here and I can just return whatever that code is. So I can say return and I can paste in that exact code. This should be taking in my user property. Make sure we import this function. It'll import our subject function as well. And now this does that check for me. So everywhere I would normally write out this check, I can instead just call can toggle to do, and I can pass it in a user, which is my current user, and a to-do, and that's all I need to do. All of the rest of this code could be completely removed, and it just massively simplifies my code. You can see all of my logic is still working exactly the same before. If I log in with a user real quick, you can see that they have the ability to modify their own to-do properties, but not the admin's to-do properties. Now you may also remember earlier in the video how I talked about how we don't actually need to pass in a subject here of an actual type. We can just pass in the string to-do as well. And that's something I also want to be able to handle inside of this application as well. So I'm going to make it so that this to-do property is optional. And then we can just say here, if our to-do is null, I essentially want to return this exact same check, but instead of returning the actual to-do object, I just want to check for any to-do. And this now checks, if I don't pass this to-do, it checks, can I update the complete property of any to-do in the database, at least one of them. And this is checking, can I update this specific to-do? So that's kind of the nice thing about Casl is you can do those two different types of checks really easily. Can I do something on a specific element? And can I do something in general on at least one of those elements in the database? So now let's go ahead and actually implement this in the back end as well, because we've implemented on the front end, but our back end is still insecure. There's no security going on. So we can go into our backend, and in this application, we're using a data access layer. If you want to learn more about a data access layer, I'll link a video in the cards and description for you that talks all about data access layers, but they're essentially one central place you can store all of your data access for mutations and queries. So in our case, our function for updating our to-dos is directly inside of here. Same thing here with create to-do, and same thing here with delete to-do. We also, inside this application, have actions, and these actions are essentially the code that's being called from the server and being passed up to check if we can do various different things inside of our different applications. Now what I want to do is I want to go into the function for my mutations here, and you'll notice that I have one right here for updating to-dos. Now I don't technically have a function that directly maps one-to-one to can toggle to-do, which makes sense because on my data access layer, I don't need that fine level granularity. So let's go ahead and also create a can update to-do function real quick that we can use inside this mutation here for the update to-do, because this will work for both can toggle to-do and can update to-do. So let's go ahead, we'll just copy this entire function because it's going to be pretty similar. And this will just be called can update to do. First of all, we want to check the user and to do properties just fine. But in our case, we don't need to check the individual keys right here. We can actually remove that section entirely. And now what this code is going to do is it's going to check, can I update this to do? But it's not checking any of the field properties at all. We want to make sure we also check the field properties. So we need to pass in a third parameter, which is like whatever the thing we're updating the to-do to be. So we can call this whatever we want. In our case, we're just going to call it data. And this data is the thing that we're updating inside the to-do. We're going to, again, make sure that this is optional because we don't always need this to be passed along. And this is going to be type of from our to-do table. We're going to be doing the infer insert. And since this is an update, this is a partial property. So now essentially we're getting all of the different data, and these are the key value pairs that we're going to be updating inside of our application. Now in our case, we only care about the keys because in some case, when we update an entire to-do, this is going to have something like the name that's being passed along, and it's going to have the complete property, which is like true, false, and other related properties, such as public is going to be on here as well. But when we're only toggling a to-do, the only thing getting passed into that data is this complete property. So we essentially need to loop through this object and get all of the different keys and check to make sure the user has permission to update those before we do our update. So what we can do inside of here is we can do a simple object.keys, and we can loop through all the different keys of the object that we're wanting to check. So let's just pass in our data into this particular object, and then we can do a simple check for this. And we want to do an every check to make sure they have the ability to update every single key. So in our case, this will be a field. And now inside of here, we can just return calling this get user permissions, and we can pass along each individual field just like that. And then we can return this as our actual object that the user is going to be using. Let me just minimize that down. So essentially, whenever we pass in the data, we're looping through every single key of that data and checking to make sure they have the ability to modify that individual key. But we only want to do that if our data is not equal to null. So if our data is equal to null, then we essentially return our data as before without checking each individual key. And if we have data, then we're going to check every single individual key of that data. So let me take a look at what this function looks like when we call it. If we call can update to do, and we just pass it in at user, in our case, we'll just pass in undefined. This just says, hey, do we have the ability to update in any to do inside of our application at all? If so, then that's fine. If we can update at least one to do, this will return true. Now, if we have an individual to do that we're checking for, we can pass in all the data for that to do into here. And now it's checking, do we have the ability to update this individual to do? And if we want to go a step further, we can pass along this data property, and this is going to pass along, for example, the completed property to true. And now this is going to check, am I able to update this particular to-do by changing this particular property of it? So this is going to be how we can get all those different fine-grained controls on what we're checking in our application. So let's go into our application. We're going to go into that mutation section, and here's where I want to implement that check for can update to do. Because I want to be able to pass in my user information, my to-do, as well as my data-related information. So I already have my data, which is great. The next thing I need to do is get my to-do as well as my user. So I can say const, I want to get my user and my existing to-do. I'm going to put this inside of a promise.all, so we can say promise.all. And I essentially want to get my current user. That's going to get my user property. And then for my database, I could just query my to-dos, and I want to find the first one. And since I have an ID, I could just do the first one where my ID is equal to the ID that I pass in, just like that. That's going to give me my existing to-do, which I can use right here. So now I have this nice can update to-do function that determines, okay, based on this particular user and this to-do that they're trying to update and this data that they're trying to change, do they have permission to do all of these different things? So now I could just say, if they don't have permission to do that, then I want to throw some type of error. So we can just say throw a new unauthorized error. There we go. We're going to call that unauthorized error, and we're actually going to create that error. Also up here, we can say if the user is equal to null, then we can return by throwing a new unauthenticated error, just saying that the user is not currently logged in. Now I'm going to go ahead, I'm going to make sure we create this brand new error. So inside of where this function is, I'm just going to copy the unauthenticated error, and I'm going to return an unauthorized error instead. This is just going to say unauthorized, and this is going to say unauthorized error. Make sure I get that typed in there correctly. There we go. And now we can use this inside of our code here. And now we're essentially returning that specific type of error, which we can use and handle however we want, where we call this update to do function. Other than that though, all the code inside of here stays the same. Literally the only thing that we're changing is we're checking, does the user have permission to do this thing with these particular properties on this particular to do? And now wherever I call update to do, I can make sure that I use all those different errors properly. So let's go into our code and find where we did that. Inside of our actions is where we call this update to do function. I already have a try catch. So let's come in here and handle our error properly. You can see up here, I'm already handling the unauthenticated error. So let's just do that exactly the same. If we're not authenticated, redirect them to the login. Or if the E is an instance of unauthorized error, well then we know that the user is not authorized to do this. So we can just return an error to the user. And we'll just make it look something like this. That just says, you do not have permission to do this. There we go. So now if they are unauthorized, we give them an error. And if they're unauthenticated, we redirect the user like we should be. We also need to make sure we do the exact same thing in our toggle to do function down here. So let's copy that down because this is really the main thing that we're currently checking for all of our code right now. So currently we have all these permissions set up. So if I try to toggle something that I don't have permission to, I should get a warning. So what we can do is we can toggle these things. You can see it's working exactly as we expect. We can go into our page, and I'm just going to remove that permission check from the client side, because now we're only checking things on the server. So if I were to try to toggle one of these admin to-dos down here, you can see I get an error. You do not have permission to do this. It's just showing up at the bottom. I will move where that toast is though, just so it's a little bit easier for you to see. So we'll come in here where that toast is being at, and we'll say that the position on this is going to be on the top. So now when I click on this, you can see up here, you do not have permission to do this, which is exactly what we want to show up. I can also show you that this is specifically working in the case of only allowing certain properties to be modified as well. So let's go ahead, we'll remove the toggles from both of these. There we go. So now at least those check marks are disappearing. I'm going to sign in as my admin user, because we know the admin user only has the ability to update the completed property of to-dos they don't own. So you can see here, I'm able to update these just fine. But if we actually change the code for this, so if we go into our actions, you can see here's our toggle update action. What if I were to come in here and say that it also changes the name to test? So now it's not only changing the complete, and I believe this is called something other than the name, it's called title, there we go. So now we're changing two properties. One of them we have access to, and one of them we don't. So we should get an error. So if I try to modify this on my user and I click on it, you can see you do not have permission to do this, because now I'm trying to update a permission or an object here that I don't have access to, because I can't change the title. I can only change this complete property. Now you can see I can toggle it fine, that we're no longer passing along that title property. And again, the reason all of this code is working like we expect it to is because of one simple function that we created. If we go all the way back into our permission section for our to-dos, this nice little function right here for can toggle to do and can update to do, this is handling all the complicated logic for us all in one place, so we can just reuse this super easy to use function everywhere we want. And by having a data access layer to handle everything, it again makes it really easy to handle all these different permission related codes, because our actions are relatively straightforward. Just call the data access layer and check our different things for the errors being thrown. Now to show you just how simple this is, I'm going to do the exact same thing for deleting and creating, and it's going to take almost no time at all. So let's come in here. To do the same thing for delete, we need to make sure we listen to the exact same errors. So let's come in here and handle those errors properly for unauthenticated and unauthorized. We can do the exact same thing if we scroll all the way up to our create section as well. We're currently handling the unauthenticated, so let's just do unauthorized, paste that in. So now we're handling all those different types of errors. So now all we need to do is make it so that it throws those errors when we call, for example, delete to do or create to do. So let's go into our delete to do function and work on that one first. Now, just like in update to do, we essentially need to get all of our user information. So I'm going to kind of copy all of this over because it's very similar between the two. First, we get our user and the existing to do that we want to do. Then we come in here with a can delete to do that's going to check, can we delete this particular to do? We don't have any data we need to worry about passing along to it. We just want to check, can we delete a to do, because there's no field related stuff to worry about. And what we can do is we can go into that can delete to do function and create it. So where we have can update to do, I'm just going to copy this and we'll say can delete to do. This can delete to do, like I said, doesn't take any data properties, so I can get rid of all of these different data checks that we have. And essentially all I need to do is change update to delete, and that's all that there is to it. Now I'm checking, do they have permission to delete a to do based on all that information. If I come back into my code and I import this can delete to do function, you can see all the errors go away, and that should be everything I need to do to handle the delete permissions inside my application. Now it's only handling it on the server currently. We'll get to the client side section in a bit, but if I go over to the my to-do section, you can see that I can come in here and I can delete some of these to-dos if I want. We know that it's impossible to delete a public to-do, so if I delete this public to-do, I should get an error. When I click on this and I click yes, you can see you do not have permission to do this because this is a public to-do. If I delete this private one down here though, it should work fine. You can see that that deleted just like we expect. So now let's just go ahead and make sure that on the client side, we are rendering out these different things. So we're only showing the buttons that they have access to at the current time. So all we need to do is find that page. So in our app, in the my to-do section, this is where our entire form is for all this related stuff. And we can see we have, for example, this to-do checkbox. We should put a check inside of here that just essentially says can toggle to do. We need to pass it in our user, which I don't know if we have it all. We do, so we can just say user. And we need to pass it in the to-do we're checking for. And if they have the ability to do that, then we can render out this to-do checkbox. So now this checkbox is only showing if they have permissions for it. Next thing we can do is we can go down a little ways and we can find the delete button and the edit button. Here is our edit button and here is our delete button right here. So we can just wrap those in the proper checks. This one is going to be can update to do, just like that. And then for delete, we essentially want to do the exact same thing. Make sure we get this right there, but this is can delete to do, just like that. And now you can see those delete checkboxes or delete buttons have disappeared on these two that we can no longer delete. So now we have client-side enforcement and server-side enforcement, which is really important. And the best part is since we have that data access layer, it's really easy to make sure that we have server-side validation, which is the most important part. It's okay if the delete button accidentally shows up on the client side, as long as you prevent it on the server side, that's what's most important. So now that we have delete done, let's just go ahead and copy this exact same thing, but we want to do it for create as well. So let's just copy this over, we'll paste this down. This will say can create to do. We pass it in the user and optionally the to do we want to create. Here we can change this to create, and now this entire function is already done, so rather straightforward for us to do. We could even go further and create like a helper function that wraps all of these, but for now, this works perfectly okay. Then we need to just make sure we use can create to do in all of our different locations. So first we're going to go into our data access layer, and we're going to make sure we modify this here. So inside of our create to do, we want to check to make sure that the user can create the to do before we do anything. So we can just say here, if can create a to do, just like that, we're going to pass it in our user, as well as our to-do, which is just all the data that's being passed into our function, just like that. And you'll notice we get an error because this data doesn't have a user ID, so we actually need to make sure we pass that in. So we'll say const new to-do is equal to all of our data plus the user ID from our user, just like that. And then we can pass that in as our to-do here. So now we're getting that information checked properly for our to-do, and we could rename this to new to-do data. I think that'd probably be a better name. There we go. We can use that exact same thing right there, new to-do data, and we're still getting a little bit of an error, and that's because in our can create to-do, this should be infer insert because we're doing an insert, not an update. So there we go. We are inferring just the insertion portion of the to-do. Now if we go back here, that gets rid of that error, and we can return our error inside of here. So we'll throw a new unauthorized error if they cannot create the to-do. So again, all the rest of our code above and below stays the same. It's just one small permission check that we have inside of here that handles everything else for us. And I think inside of our action, we've already handled our unauthorized error up in our create section. So let's just make sure we check. Yes, we are handling that right here. So at least we're now checking that permission properly. Let's go ahead and do the exact same thing on our client as well. So let's scroll all the way up to where we have that to-do modal. This is what allows us to add a to-do to our application. We can just say can create to-do with our user and our to-do information. In our case, we don't have a to-do, we just have the user information. We just want to know, can they create any to-do at all? Then we're going to render out our to-do modal, just like that. And that's why this function, if I go back to that real quick, has the ability to pass in the to-do as optional, because again, sometimes I want to check not an individual to-do, but just can they do this thing in general? And now this button will disappear if they don't have permission to do that. So if we go into our actual permissions and we modify it so that users cannot actually create, so we're going to say that they can't create things at all, we'll just get rid of this permission and we save. You can see that button has disappeared. So we know that this is hooked up on our client and on our server. And you saw how easy it was to create these permissions once we kind of got the framework and system in place. So now let's go ahead and actually move on to doing queries, because so far we've only dealt with mutating data, but we haven't dealt with reading data, which is actually much more complicated than you may think, because now we're dealing with actually accessing data from our database, and we only want to get the data from our database that is able to be read. For example, here, we only want to be able to read the public to-dos, or we only want to be able to read the to-dos the user has access to. So we're going to start with the user section first, and then we'll move on to the more complicated code of dealing with to-dos. So inside of our code, let's just kind of minimize all this down. We'll go into our data access later for our users, and we have this queries function right here. This just gets all of our different users. So when we go to the user page, you can see it tells us how many to-dos they have, as well as all the information for each individual user. And what we want to do is we want to just throw in a quick permission check here to make sure we have permission to view this data. So we can come in here and we can get our user permissions is equal to get user permissions. We can pass it in our user, which we need to get up here, const user equals get current user. Make sure that we await that. And now with our permissions, we can say, if we don't have the permission to read users, well, then we can just throw that new unauthorized error, or there you go, unauthorized error, or do whatever else you want inside of here. Now again, for the user section, I'm showing you the quick and dirty way of doing things because we don't have any permission helpers set up or anything, because these are quite straightforward, and I want to show you the multiple ways to do things, while when we did things in the to-dos, we had these nice little permission helper functions set up. Now technically this would work as is, but if we were to modify our permissions, we would actually need to modify this a little bit. For example, if we made it so that we can only read users, where the role is equal to user, not admin, then we would need to modify our code a little bit, because right now you can see we have our permissions for user. We need to get our user subject, so we'll say type user subject, since we're now modifying things on our user, and we're going to pick from the type of user dot infer select and I specifically only care about the role information, so we'll do that. Or it's going to be that user type, and now I can replace this with my user subject. There we go. So now you can see here, I have access to that role information that I'm checking inside of here, which is great. So now I only want to be able to get the users that have this role of user. I don't want to be able to view admin user information. And right now, when I refresh my page, you can see it's returning all the information, admin users as well as normal users. Again, that's what I want to be able to modify and change. So here, let's just come in and say that this is going to be our users. So we have our users is equal to this information right here. And I want to filter this user information and only return the users the database people have access to. So I can say users.filter. For each individual user, I want to check my permissions to see if they can read this particular user. So you know we need to call the subject function, pass it in our user, and then we pass it in our user object just like that. And if I import this function, we're now checking each user that comes from our database. We're looping through and checking to see if they have permission to view them. And if we give this a quick save, you can see that that removes the admin users from this table, which is exactly what we wanted. But this is definitely not the best way to do this. And this will actually lead to certain problems in your code, especially if you start mixing server and client-side code, because this subject function actually modifies the variable you pass to it and adds a property to it that next.js and React in general assumes that now your user object is a class instead of a normal object. And classes cannot be passed from server components to client components. We're going to get an error if we try to do that. Let me just show you what that would look like inside of our code. So we're going to go to the page that we're on right now, which is that users page. I'm going to create a brand new file. We're just going to call this client.tsx. It doesn't really matter what this component does. I'm just going to render it randomly inside of here. Again, it doesn't matter what this component does. Let's just make sure that we export something from here. Export function client. There we go. Return null. Again, doesn't matter what it returns. And inside this client, I want to pass it my users information. So we'll say users is equal to my users, which is coming all the way up here from getting our users from that function. And now if I make this a client function, we're going to get an error inside of our code. There we go, use client, give both of these a quick save. And if we refresh, you can see down here, we're getting an error. Only plain objects can be passed to client components. And because of the way that this Casl library works, and it kind of assumes everything is classes behind the scenes, it's actually making this into a class when we call that subject function. And unfortunately, it mutates this directly, which is not really what we want. So instead, we need to actually fan this out into a brand new object. So now this object that's being mutated is different than the one that we're returning to the user. And by doing that, you can now see our code is working as we expect, because we're not doing that weird stuff of mutating the object and passing it down as a class. So that's just one thing to be aware of that I ran into when I was writing out the code for this particular project. Now in our case, we don't actually need this client or anything like that, so let me just delete that code so we can get rid of it, since that was really there just for demonstration purposes. But if you're going to write your code out like this, you're going to need to do all this extra stuff. So we need to filter through all of our different rows, we need to create a brand new object for each one, and if we have hundreds or thousands of database records and we only have access to like 2 of them, this is obviously a huge problem, because now we have all this extra code being written and looped through, and we just want to throw it on our database where we can just say like where the role equals user or something like that, where we only want to get the non-admin users. I want that to be the simple stuff that we do. So when we look at how we do this with the to-dos, instead, I'm going to make a really simple adapter that hooks into Drizzle that does all that calculation automatically for us. So let's go into the data access layer for our to-dos. We can go into that queries section right here, and I have 2 functions, the ability to get all of the users to-dos and to get all the to-dos with users. That's essentially our homepage data right here. And this is the first one I'm going to look at. So we can do a quick little check to see if we can read a to-do, which we don't have a function for. So we're going to need to create a function for that. And it's going to take in a user object. So we can say const user equals get current user. Make sure we throw a little weight on that, just like that. And now we have this can read function. And if we can't, we can throw a new unauthorized error, just like that. So let's go ahead and create that function. We'll go into our permissions for our to-dos. And I want to create a brand new function. We'll just copy this one up. Can read to do. Now this code's pretty much the same. This is going to be an in first select because we're selecting it to do. And this is going to be read and read. Super straightforward. That's all that we need to do inside this code to make it work. And if we go ahead and we import this can read to do, we now make sure that at least we have the ability to read the to-dos before we run this function. But again, I want to make this even better, where I can just say where, and I want to get only the to-dos where I have access to something in particular. So I'm going to create a little helper function called drizzle where, and this is going to convert our permissions into a drizzle where query, so it only returns the to-dos we have access to, and it doesn't do any extra stuff. We don't need to worry about filtering or the subject function or anything like that. So what we can do is we can pass it in the action we want to perform. We can pass it in the subject we're doing this on. We can pass it in our user object, as well as the table that we're trying to query. So we're querying our to-do table with our user. We're trying to get to-do objects, and we're trying to read them from the database. And I'm going to convert all of this code into an actual drizzle where query that we can use in our application. So essentially, this would convert to something along the lines of like equals, which comes from drizzle, and then it's going to say to-do dot public is equal to true because we're only getting it when the to-do property is true. And we can also throw in an or here. So this is going to have an or just like that, or equal to-do.user_id is equal to our user.id. That's kind of what the query is going to look like, because if we're on our user account, we have access to that information. And since we're an admin, we actually have access to everything. So this to-do where query would be empty. But if we're a user, this is what that query would generally look like. And if we're not logged in, our query would look like this instead. So we need to be able to dynamically create this query for us. So let's go ahead and actually work on creating this drizzle where function. Inside of our permissions, we'll just create a new file called drizzle adapter.ts, just like that. And we'll export a function called drizzle where. Now this function is going to be quite complex, but we know that it's going to be taking in an action. It's going to be taking in a subject, a user, and then it's going to be taking in a table. And for this particular code, we want to call a function. So we're going to call get user permissions, where we pass it in our user object, and that's going to return to us our permissions. And the permissions can actually be passed to a function called rules to AST. This is a function that we can get if we just import it. Let me make sure I copy this up. And this is from that @Casl ability, but we get it from the extra library instead. And what this essentially does is it converts these permissions into an abstract syntax tree, which is just a much easier way for us to actually read the different things that are going on. So we can say rules is equal to that. And then we can say down here, rules dot, you can see we get a value and we get an operator. So the operator is like equals, less than, greater than, and so on. And a value is going to be the thing we're comparing against, like true, false, and so on. So we can actually use this to be able to get all the different information that we need. Also inside this rules to AST, we need to pass it along what the action and the subject of that property is going to be. So now we're getting our user permissions and we're passing along the action and subject we're trying to do that for. Now we obviously need to type everything up here, which is where the code's going to get quite complicated. First of all, we need a generic type because that type is going to determine what our table is. So this is going to extend the table config, which comes directly from Drizzle. We want to make sure we get the Postgres one because we're using Postgres. If you're using MySQL, get the MySQL one, and so on. And then our table is going to be equal to a PG table with columns, again, because we're using Postgres. If you're using a different database, you could use the correct type for that. And we want to get the generic type specifically for that. So now our table is going to get the correct information based on whatever table we pass in. So if we pass in the to-do table, it's going to use the to-do table. If we pass in the user table, it'll use the user table. Our user right here is just our type from the auth library that we're using. So we can just copy and paste that in directly. We already know what that type is going to be. And action and subject, this is where it gets a little bit more complicated. This is because we're going to essentially take the type of our get user permissions. And essentially what I want to do is get the return type of this. So I can say return type of my get user permissions. On this particular thing, we have a function called rules for, which is very similar to this rules to AST, but it's specifically on this as well. And this allows me to get the parameters from this. Parameters. And the parameters of this function is going to be an action and a subject. So the very first one I can get is my action, and I can do the exact same thing for my subject, getting the second parameter just like this, and that'll give me my subject property just as well. So now I have access to both my action as well as my subject by using this nice little hack essentially to make sure that this is typed to the types that I have here and my subject is typed to these subject types that we have been using. Essentially, this complicated TypeScript code just hooks into this function and gets all my permission type stuff that I've already created inside of here, so I don't have to recreate that in multiple places. Now we're going to call this our AST because essentially this is our abstract syntax tree. And if our AST is equal to null, then that means there are no permissions currently affecting this user. They have access to everything. So we're just going to return undefined just like that. That's how Drizzle works. If you use undefined for the where clause, it just does nothing at all. Otherwise, we want to call a new function called getConditionSQL. We're going to pass it in our AST as well as our table, and we'll create that function down here. GetConditionSQL. which takes in an AST and a table. Now this table, we already kind of know the type of it. It is going to be the PG table with columns, and that's going to be a generic type. And that's going to be table config, again, making sure we get that from the right location. And then our AST here is going to be the type of condition. That's essentially what this type is here. You can see we have an unknown condition, which is what the type of this is. Now, what we need to do is be able to determine what that type of condition is, because different conditions do different things. So we can say if condition is an instance of a compound condition, there we go. Then we want to do one thing. Otherwise, what we can do, and we'll call this condition instead of AST. There we go, so it's a little bit more clear. Otherwise, if our condition is an instance of a field condition, that means we want to do something else. Make sure I call this instance of, there we go. A field condition is essentially something that has a field property. So you can see here, we now have a field property. So like equal to something else. And a compound condition, if we look at that, has an array of different conditions in the value property. You can see this is an array of conditions. So this is how we are able to determine the difference between these different things. And inside of these, we just want to switch through all the different queries we want to do. So for example, I could do a quick little switch right here on my condition dot operator, just like that. And if my operator is equal to the equal sign, that means I'm trying to do an equal equation. And I can just come in here with a quick return that returns a function called drizzle equal, where I pass it in my condition and my table. And this is just a function we can define. So we can say drizzle equal takes in a condition and a table. And our table syntax is essentially the exact same as before. So I'll just copy that over from our previous section, just like that. And our condition here we know is a field condition because we've already done that check up here. And now that we have that field condition, we can do something with it. We can just return calling the equal clause with our table. We want to get the property, which is our condition.field, and we want to get the condition.value. So all I'm saying inside of drizzle is get the field from my table. So for example, if it's public, it says get the public field for my to-do and check the value. Is it true? Is it false? So if we look at our actual get user permissions real quick, you can see here I have public and I have it set to true. Public is the field and the value is true. So inside my code inside of here, what I'm doing is I'm saying, hey, with my table, which in our case is like to-do, I want to get the public property. So it says to-do.public like this. And then I say that that is equal to my value of true. That's essentially what these two sections are filling in. So now we just have the ability to create this equal clause automatically for us. And this is automatically hooked up with all of the code that we have inside of here. So now when I call this code, if I have an equal queries, it's automatically going to handle that for me. Now I could get much more complicated and add less than, greater than, and so on, but in our case, we only are doing equals. So instead of making you watch me type all those out, we're just gonna throw in a little default case here, and that's just gonna throw a new error. And that error will just say unsupported field condition operator. There we go. And let's just put what that operator is. There we go. So now it's just making sure it handles our operators. And if we have one we don't handle, it'll just throw a nice little error for us. Now we obviously need to do the same exact thing up here as well. So we're going to switch through our condition.operator up here. And we have a case essentially for an and clause. And we have a case for or, and we need to handle both of those, as well as a default that essentially is just going to do the exact same thing as our other default. This one is going to be compound. There we go. Now for both of these, I'm essentially just going to be calling the drizzle and function and the drizzle or function, just like I was doing before. And we can essentially create a drizzle and function, which we know will take in a compound condition. And we can do the exact same thing for our drizzle or, which again will take in a compound query. And this and is just going to call and we need to pass it in all of our information. So let's make sure we import and down here for or, we're going to import or. Now we already know that our condition has a value property, which is an array. And what we want to do is we want to take that array of individual conditions, because it's just an array of conditions. And I want to call the get condition SQL, pass it in my condition and pass it in my table. So essentially all that this code right here is doing is taking my conditions, looping through them and getting the SQL for them. So all the equal clauses and so on inside of here are going to be converted to equal clauses that Drizzle can understand. And if we just spread that out, we now essentially have the ability to use this inside of our application. Now we are going to be getting an error because we're essentially recursively calling this get condition SQL function, which means we need to give it an explicit return type. We know that this is going to return SQL, or it's going to return undefined. So we can just give that a type, and that solves our type information down here. And to solve or, we essentially do the exact same thing, but we just call or instead, and we're again getting all of our different condition SQL. And that's all it takes to create this adapter. I know this is quite confusing with all the code that's going on, but if you want to play around with this code, all of it's going to be linked in the GitHub down below, so you can actually look at this code, play around, and see exactly what's going on. But this now essentially converts our permissions into a Drizzle query. And if I were to just import that Drizzle where function we just created, now it's automatically going to only filter the to-dos I have access to with this particular function. So let's just give that a save, and we're going to look at our code here, and you can see the admin user has access to all the to-dos. Every single one of them right here is showing up. But if I sign out and I log in as a user at test.com, I type in my password, you'll now notice that I have access to all of the user to-dos, but all of the private admin to-dos have been completely removed. And when I sign out, you'll notice that all the private user to-dos are removed because this Drizzle query is automatically converting my permissions into a Drizzle where query that handles all of this logic for me automatically. Now, the best part is I can just take this Drizzle where query, I can come up to my get user to-dos, and I can just combine them together. So I can put a little and query inside of here, make sure I get that imported, paste in my normal query of an equal, and I can throw in all of my other Drizzle where query related code, and it's just going to AND those together. So now when I access the my to-dos page, it's also only going to return the to-dos that I have access to. So if I log in to user at test.com, and I go over to that my to-do page, it's now making sure to filter this to only the ones I have access to, which in our case is all of them, but still, if there was some that I was restricted from accessing, this would make sure to remove them. Now, if you enjoyed this video, you're definitely going to want to check out my data access layer where I show you how to create a super advanced data access layer inside of next.js, but it really works for any library out there. And also, if you want to deep dive into permission systems, I have a full video creating our own permission system entirely from scratch that has all the same functionality as Casl. You can check that video out. It's also going to be linked on your screen right over here. With that said, thank you very much for watching and have a good day.